So I'll go over a couple of observations.
Yeah, try that. Try observing. That'd help.
Contextual statements regarding what we sort of have learned through this process that,
You haven't learned anything.
I shouldn't have to just keep doing this over and over again.
No, you shouldn't, because you've been proven wrong so many fucking times.
Because there are facts here that have been acquired that,
Yes, facts. Proof has been shown to you, but you just don't seem to get it.
Change one's perspective on the experiments people are using to make arguments. So going all the
Yeah, making arguments that you don't counter, really, is just bullshit.
way back now, maybe even 3 years ago. Alright, so in this argument, the Brozo did an experiment that was accidentally, okay, I'll say, quite well done, in the sense that he created a lever.
Right, so the one, let's just get this fact right, one experiment that had a flaw in it that you spotted is somehow well done because it come out close to your bullshit predictions. This is the raw footage of the one mass launch. It's filmed in about 2,000 frames per second. You're under the impression that it stops just after where I timed it or measured the time. No, it doesn't. It continues on for a further 15 centimetres out of shot. The reason it stopped where it did is because I froze the video because I didn't think anybody want to see it just going along very slowly. Unbelievable. But anyway, no, it doesn't stop there. It continues on for a further like 15 centimetres. The reason it's going slow is because it's in slow-mo. And because on the other two, obviously, because they're moving faster, they move through the shot completely slow-mo. This one, boom, at the end. There you go. This is the half-mast launch, raw footage, again, in about 2,000 frames a second. So as it's launched, it's in slow-mo. It continues on. It goes roughly about 50 centimetres. The ruler, as you can see, it only goes up to about 20. So it continues on about 30 centimetres out of shot. As the slow-mo only films for a certain amount of time, this actually travels further in the slow-mo, obviously, because it's got that window of time. I think just about at the end you can maybe just see the slow-mo kick out and it shoot off. Quarter mass launch here, the one that you pretend doesn't exist because it shoots your theory to shit. The other reason for measuring where I did as well is the camera is fixed above, and as they move under, they're almost in a point where it's directly under the camera and in line with the markers, so therefore it's a fair test. Because I actually thought about what I was doing. You don't do experiments, you don't think, you just talk shit. Quarter mass, raw footage launch. This one, obviously, because it's going faster, stays in slow-mo the entire time. If you're so concerned about where it was measured, as you can see, there's a physical ruler there. So what you could do is you yourself could actually time it from a closer distance to where it's launched. And then you would still find that it comes out exactly as conventional science would predict. But you won't do that, will you? Because that'd prove you wrong. You can make all the excuses under the sun, but you're still wrong. I could time it with timers and you'd still deny it. This is going roughly twice the speed, therefore it will go twice the distance, not 4 times the distance like you keep claiming. It's not rolling, it's sliding. It's going twice the speed, it will go twice the distance, which it does, which is around 70 centimetres.